Okay, so if you got any question, please ask. Okay, please just ask. All right, so let's begin. So this is Kelantan, section B. Okay, diagram 9.1 show the image of a pen placed under convex lens X that has a focal length of 5 centimeter. Okay, so one thing that I want to point out, that I want to stress that is very important is please make sure that you read the question completely from the beginning until the end. Some students, they want to rush, they want to save time, so they think that they thought that, oh, that the beginning of the question, all of those introduction is not important. Okay, but however, you can see from here that there are important information inside this introduction or the beginning of the question. Okay, it got give the focal length of the lens. So if the focal length of the lens they give here at the beginning of the question, that means later on in the later part of the question, if they use the same lens, convex lens X, they will not give you the focal length 5 centimeter anymore. They will expect that you already know, you already read the question carefully, you already have the information. So they will not tell you that, okay, the focal length is 5 centimeter one more time down there. Okay, so you can see that this convex lens S can produce an image that is magnified. Okay, that's magnified. All right, so first A, what is the wave phenomenon involved in the formation of the pen's image? So what kind of wave phenomenon is this? Okay, thank you. Very good. Refraction. Okay. Refraction. Okay, you can say refraction also, alone also, or you can say refraction of light or refraction of wave also can. However, if the question say what is the light phenomenon involved, then it would be better if you say refraction of light. Okay, if the question asks for what is the light phenomenon involved, you say refraction of light. It is better, okay, it is better. Okay, so very good. Next, okay, B, explain how the focal length of convex lens X in diagram 9.1 can be determined. Okay. All right. So, how to get the focal length of convex lens X? Okay, first we need to know what is the focal length. Focal length is the distance from the lens to the point where the light focus. And that point we call it focal point. Okay, right, we call it focal point. So how is it that we can find out where is the position of the focal point? If we know the position of the focal point, then we can measure that position to the center of the lens. Then we can get the focal length. So how do we do that? That is what we want to explain here. So to answer this question, we can draw diagram to help us describe. Okay, to help us explain, we can draw diagram, and the diagram can have marks. Okay, so we draw a simple ray diagram. Okay, we draw a simple ray diagram. All right, so this is the convex lens. Okay, label. Okay, convex lens. Okay, so here, this is the focal point. All right, now, what kind of light will bend and refract towards the focal point? Lights that are parallel to the principal axis. So this line at the center here, this is the principal axis. Okay, the principal axis. So the light ray that are parallel, okay, light ray that are parallel to the principal axis, they will refract and they will pass through the focal point. Okay, refract and pass through the focal point. So here you can label here to here the distance, here to here as the focal length. Okay, focal length F. Like that. Okay, now this diagram alone maybe already have 1 or 2 marks like that. Okay, out of the 4 marks. All right, now in order to back up or we use the diagram to explain, to make our explanation more clear and more complete, so we have to write sentences. Okay, so the first thing is we say point oops, lights that are parallel to the principal axis through the convex lens. The light rays will focus on the focal point. And then you just say measure the length between center of lens or optical center also can, between center of lens and focal point to obtain focal length, okay, of the convex lens. Okay, just like that. All right. Okay, so very clear how to get the focal length. Point lines that are parallel to principal axis through the convex lens. So either you can say, okay, point lines that are parallel to principal axis, or you can say position the lens. Okay, or you can say another way beside this, another way that we can get the focal length is we say that we place the convex lens so that lights from objects that are very far away will pass through the lens and focus on a piece of white paper. Okay, adjust the distance of the white paper to get a sharp image, okay, formed on the white paper. And then after that, you say the position of the paper is the focal point. And then lights that come from objects that are far away are parallel. Parallel lights parallel light ray will pass through the lens and focus at the focal point. And then last, you say, measure the distance between the paper and the center of the lens to obtain the focal length. Like that lah. So that is another way that we can obtain the focal length. Okay. Okay, continue. Wait, Okay, C. An object with height 2 centimeter is placed at the distance 10 centimeter in front of convex lens X. Calculate the image distance for. Okay, so image distance is V. Okay. It says that place at the distance 10 centimeter. So that means this is the object distance. This height 2 centimeter is the size of the object. Okay, size of the object. Usually we use the capital H to represent size of object. Okay, capital H. All right. So we want to calculate this image distance. So in order to calculate the image distance, we can use, we can use the lens equation. So the lens equation is 1 over u plus 1 over v equals to 1 over f. Okay, so information that we have the object distance, and then we also have the focal length that is given early in the question. Okay, early on in the question already got give us the focal length, which is 5 centimeter, if I'm not mistaken. Okay, so one substitute inside 1 over u, the object distance 10 centimeter. Okay, plus the image distance 1 over image distance over 1 over the focal length, which is 5 centimeter. Wait, let me just confirm. Yeah, focal length 5 centimeter. Okay, so maybe some of you will think, sir, why no need to change to meter? Then only put inside here. Need to change to meter or not? Okay, no need to change into meter. Why? You can straight away put centimeter inside because all of them are centimeter. This one also centimeter. This one also in centimeter. So later on, this V that you get will also be in centimeter. Okay, so this image distance will be 10 centimeter. Okay, you will get 10 centimeter for the image distance. Okay, so you need to change the unit so that all of them are the same. Okay, if some of them are different, for example, some information given in centimeter, some given in millimeter, some given in meter, then you have to choose one unit and stick on it. Okay, and you convert all the other unit into that unit that you choose. For example, okay, you like meter, so everything change to meter. Okay, information that is in centimeter change to meter. Information that are in millimeter change to meter. Everything change to meter. Okay, this depends on you Okay, if you like centimeter, then everything change to centimeter. Most important is when you want to put into this equation, all of the unit they must be the same. Meter or meter, centimeter or centimeter. Okay, all right. So you get image distance 10 centimeter. After that, second, the linear magnification of the image. Okay, so how to calculate the linear magnification? Okay, one way is you take the image distance over the object distance. Okay, you can get the linear magnification, this number. So this number, linear magnification, is a number that tell us how many, tell us the ratio between the image size and the object size. Okay, all right. So in this case, the image distance is 10, object distance also 10. So you get 1 lah. So if the linear magnification is 1, it means that the size of the image is the same as the size of the object. The height of the image same as the height of the object, both same height. So the third part, I want us to calculate the height of image. Height of image same as height of object. So height of image, image height equals, just now is what? 2 centimeter, okay? Height 2 centimeter. All right. So just like that, very simple. Okay, let's continue. Okay, so part D. Okay, part D. This one is the 10-mark question. Okay, so convex lens X in diagram 9.1 is combined with convex lens Y that has a focal length of 50 centimeter to make a simple telescope. Okay, to make a simple telescope. Okay, so we have PQRS, 4 different configuration or 4 different arrangement of the lens. Okay, so let's look at the question. Okay, you are required to determine the most suitable method to build a simple telescope based on the following aspect. The first one is selection of lens as objective lens and eyepiece, and then comparison between focal length of objective lens and eyepiece, and then distance between objective lens and eyepiece, diameter of objective lens. Explain the suitability of the aspects and determine the most appropriate method to build a simple telescope that can produce a brighter and a clear image. Give reason for your choice. Okay, it is very important to, like what I say, read the question from beginning until the end. Read every word. Okay, read every word, pay attention, think about what is it that the question is talking about. This is very, very important. Okay, so explain the suitability of the aspect, and then to build a telescope, a simple telescope that can produce a brighter and clear image. Okay, so you see in the question already got these two words, brighter, clear image. So that means later on in our explanation, we cannot use these same word. We cannot say, okay, why we do this modification and why we choose this, so that to get a brighter image. Wrong. Okay, wrong. Okay, cannot. Okay, if you say so that can obtain a brighter image, no, 0 mark, you don't get mark. That means because it says it is as though you are copying from the question. Okay, you are just copy from the question. You are not giving your own answer. So no marks. Understand? Clear image also same thing. If you say why we do this, why we choose this, so that we can get clear image, also cannot. Okay. So it's very important to highlight. Okay, you read the question, you highlight what are the words that used inside. Okay, this part, the objective of the question, to build a simple telescope that can produce a brighter and clear image. So this one cannot use as your explanation. All right. So this type of question we answer in table 4. Okay, although it is not compulsory. Okay, although it's not compulsory to answer in table form, you can answer like story also. Okay, like essay like that, all stick together also can. But if you answer in table form, you organize your point clearly, the marker, the examiner, the marker that mark your paper would thank you. Okay, it will be easy for them to find your point and easy for them to give you marks. Okay, if you write all jumble up, then not only that, okay, you write everything all stick together like essay, like a story like that, then you make it very difficult to identify your point. Okay, then cannot give you marks. Okay, cannot find your point, unable to give you marks. Okay, right, cannot find your point, then cannot give you marks. So make sure you organize your answer, you present your answer neatly, tidy. Okay, so the examiner easy to read through your, what is it, your answer, and easier to give you marks. Okay, like that. Okay, so this on the left is aspects. Okay, and then this one is explanation. Okay, so let's look at the first one. Okay, so this one, the first one, it says selection of lens as objective lens and eyepiece. So we need to choose the suitable lens for objective lens and for eyepiece. So which is suitable for objective, which is suitable for eyepiece. Okay, to tell the truth, for this question, you have to really understand how the telescope functions. If you don't know how the telescope functions, you will not be able to identify the best arrangement. Okay, you have to understand how the telescope functions. Okay, so for telescope, the first thing is eyepiece. Eyepiece lens, it must be a lens that is more powerful. And then for objective lens, it must be a less powerful or low power lens for objective lens. And the eyepiece lens is a lens that is more powerful. Okay, for simple telescope is like this. Okay, this is the arrangement. Okay, now between lens X and lens Y, okay, which one is more powerful, which one is less powerful? Okay, anybody can tell me? Which one is more powerful, which one is less powerful? X more powerful is correct. Okay, very good. How do you know that X is more powerful? Very you mean shorter focal length lah, okay? Shorter focal length. You are correct. Very good. Shorter focal length. The one that have a shorter focal length is more powerful. If the focal length is longer, that means it is less powerful. Now, the question is, why is it that if a lens is more powerful, then the focal length will be short? Why? Okay, one more time. Why is it that if the lens that are more powerful, the focal length will be short? You can straight away on the mic and talk if you want, because I got earphone. So although the speaker of my laptop got problem. Okay, can focus easier, so don't need longer focal length. Not exactly. Okay, I think maybe that you have an idea, but you don't know how to explain. Okay, maybe like that lah. I get the feeling is like that. Okay, so I want to take this chance to explain a little bit about the power of the lens. Okay, take this chance to do a little bit of revision. Okay, so you see, let's say that we have two lenses. Parallel light go in. Okay. Lens A, lens B. Okay, so which one is more powerful? B, very good. Okay, thank you. Okay, B is more powerful. Again, you see, because, okay, very good, very good. Again, because B have a shorter focal length, right or not? Okay, the focal length is shorter. However, what is more important is from this diagram, you can see the reason why if the lens is more powerful, then the focal length will become shorter. Can you see the reason? Okay, one more time. By looking at this diagram, can you identify the reason why is it lens that are more powerful, they have shorter focal length? Very good, very good. Thank you. Light refract more. Yes. It can bend the light more. Okay. Right. For example, this one, the first one, it only bend the light a little bit. Okay. If they only bend the light a little bit, then the focal length or the focal point will be far away lah. But if you can bend the light more, then the focal point will become nearer. Okay, the focal point become nearer, right? So this is the reason lah. And it's also very logical, right? Not very logical. The one that can bend more is of course more powerful lah, right? So when it can bend more, it make the focal length become shorter. Okay, very good. Okay, now, so from here we can see that because the x have the focal length is only 5 centimeter and the y, okay, x is 5 centimeter, y is 50 centimeter. So x is definitely more powerful and more suitable to be the eyepiece. So this one is suitable. Okay, this one suitable, suitable. Okay, this one not suitable. Y as the eyepiece not suitable. This one x as the eyepiece suitable. All right. Okay, this one not suitable. Okay, so now to explain. Okay, so aspect. So you say lens x as eyepiece. Lens y as objective lens. Okay, so explanation why you choose like that? You can say because lens x has greater power than y. Okay, like that. You can say like that. You can say like that, or you can say lens x has shorter focal length than y also can. Okay, next. Okay, next. Okay, here. Comparison between focal length of objective lens and eyepiece. Okay, we compare focal length of objective lens and eyepiece. So here already we compare. Okay, so you see this one eyepiece 5 centimeter, objective lens is 50. Okay, this one's 5, this one 50. So here is why is it that we want the focal length one to be longer, one to be shorter? Okay. Okay, focal. So what is it that we want is focal length of objective lens should be greater than eyepiece length. Okay, focal length, objective length should be greater than eyepiece length. Okay, so why? What is the reason why we want like that? Okay, to obtain greater magnification. Okay, in order to obtain greater magnification. Okay. So why is it that if focal length longer, the eyepiece shorter, focal length, then we can get greater magnification? Okay, one thing, the first is the equation to calculate the linear magnification for telescope. The equation is focal length of objective over focal length of eyepiece. Okay, can see focal length of objective over focal length of eyepiece. So that means if the focal length of the objective lens is longer, much more longer than the eyepiece, then the greater the magnification is going to be. Okay. Uh, okay. Next. Okay, next. The distance between objective lens and eyepiece. Okay, so which one is it that is more suitable? The distance. Okay, so you see there are two type of distance. One is they are further away. Another one is the distance between them is in such a way that the distance between them is equal to the focal length of the objective plus the focal length of the eyepiece. You see or not? Focal length of objective plus the focal length of the eyepiece equals to the length between the distance between the two lengths. Okay, so this is the kind of arrangement. And then this one also. Okay, this one also. So the length or the distance between them is focal length of objective plus focal length of eyepiece. Okay, so which one is it that we want? Do we want the eyepiece and objective to be further away, or do we want the distance to be just nice for the focal length of the objective plus the focal length of the eyepiece? Okay, the answer is we want the distance between them to be just nice. That means the distance between the eyepiece and objective lens should be equal um, to the sum of the focal length of objective and focal length of eyepiece. Okay. Okay, distance between two lens should be equal to sum of focal length of both lens. Okay, distance between two lens should be equal to the sum of focal length of both lens. Okay, why like that? Why is it that we want the arrangement like that? So that real image formed by objective lens can fall on focal point of eyepiece to be magnified. Okay, so this is the reason. So you see, the telescope. Okay, when we use telescope to look at objects that are very, very far away right now. Okay, look at objects that are very far away. So the light that come from that object that are very far away, when they will come parallel. Okay, objects that are very far away, the lights that come from objects that are very far away, the lights will be parallel. It will come in parallel. Okay, parallel come in. And then, like what we discussed just now, if parallel light pass through the lens, what will happen? The light, it will fall or it will focus at the focal point. Okay, the light ray they are parallel or light ray they are from very far away. Okay, very far away, then they will become parallel. So light ray they are parallel. When pass through the lens, they will focus at the focal point. Okay, they will the light it will focus at the focal point. So so because the light all focus at the focal point, so there will be a real image formed at the focal point. So you see, lights come in, here got image, real image. Okay, real image. So this real image, it fall on the focal point of the eyepiece, then this real image will become the object for the eyepiece. And because the real image is at the because the real image is at the focal point of the eyepiece, so what happened is the the sorry the suddenly my brain jammed. Okay. uh okay, sorry, one more time. Okay, the real image from the objective lens fall on the focal point of the eyepiece. And because it is a real image, so that means there really is light here, really got light. So this light that form the real image, it will go into the eyepiece and be focused by the eyepiece. So that means that this real image will become the object for the eyepiece. And object that is on the focal point, okay, it will form image at infinity. Okay, it will form image at infinity, a virtual image at infinity that are magnified. Okay, so the more powerful the eyepiece is, the greater it will be able to magnify the real image. Okay, get that? The more it will be able to magnify the real image. So the image at infinity that is produced by the eyepiece will be virtual, it will be upright, okay, and it will be at infinity. Okay, the image will be at infinity. So when you look at image from infinity, you will feel more comfortable also lah, actually. Okay, your eyes when you look at image, when you look at objects that are far away, you feel more comfortable. Okay. All right. So like what I say, you need to really understand how the telescope works in order to answer this question. If you don't know how telescope works, you cannot answer this question. Okay. Some question you don't even need to have physics knowledge. You just think logically, you can choose the best one. But some question like this question, you cannot. You must understand how it works. Then only you can understand. Then only you can answer. Okay, so this explains why is it that we want the distance between the two lengths to be equal to the sum of the focal length of both lengths. Okay. Now, diameter of the objective lens. Okay, diameter of objective lens. So the diameter of the objective lens, we have two choices. Either it's small or it's big. So we want the big one lah. Okay, we want the big one. Okay, we want the big one. So why is it that we want the big one? Okay, so diameter of objective lens should be larger. Okay, why? To allow more light to enter. Okay, to allow more light to enter. So that means when more light can go in, then you can get brighter image lah. Okay, if you want to write also can, to allow more light to enter to obtain brighter image. If you write like this, yes, you can write the word brighter image. Just now we say that, oh, brighter image cannot use because already inside the question. But in your explanation, if you write something extra that got marks, okay, then you can put in the brighter image inside, okay, to help the explanation like that lah. Okay. So it's not that totally cannot use lah, but you have to back it up with other point. Okay, you want to say brighter image, you have to back it up with same, allow more light to enter. Okay, or you don't need to say to obtain brighter image also can, you just say to allow more light to enter. Okay, already good enough lah. Okay, so the best one is R. Okay. Okay, R is more suitable. Okay, why? Because you copy back lah. You copy back all of this at the side here. Because they have lens X as eyepiece, lens Y as objective, focal length of objective lens is greater than the eyepiece. Uh, uh, the distance between two lens is equal to sum of local length, focal length of both lens, and then it have a large diameter of objective lens. Okay, so you write, okay, because blah 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 blah. You just copy back and modify a bit lah, so that the sentence is nicer lah. Okay, so that the sentence is nicer. All right. So until here, any question? Okay, anybody, any question? Okay, no question. Very good. Okay, if you've got a question, please ask. Okay, so wait. Okay, we will continue on to the next question, but okay, wow, wait, got something. Okay, let's continue. Sorry, got something happen. Okay, got disturbed. Okay, so let's continue. Okay, so the next one is electronic. Okay, number 10. Diagram 10.1 shows an incomplete full wave rectification circuit. The circuit consists of four diodes, J, K, L, and M, that connect to an alternating current power supply and a cathode ray oscilloscope. A waveform is displayed on the screen of the cathode ray oscilloscope when the switch is turned on. What is the meaning of rectification? Okay, very simple. Okay, rectification is the process of changing alternating current into direct current. Okay, this is what rectification is. Okay, after that, okay, B, copy the circle in box A. Complete the arrangement of diode K and M, and then explain how the shape of the tracing output wave on the screen of the cathode ray oscilloscope is produced. Then explain how the waveform can be smoothing or smoothened. Okay, now this is the kind of question where a lot of students usually make mistake. Okay, when the student did not read the question carefully. You see here it says copy the circuit in box A. So that means you need to copy the circuit in box A into your answer space, into the space that you write your answer, and then only you fill in. Some students, they didn't read carefully, they straight away answer, so they draw the answer inside here in diagram 10.1, they draw inside here. So if they draw inside here, there's a high chance that it will lose the mark for this part. Okay? Because did not follow instruction. The instruction say copy and answer and write, but did not copy, straight away answer inside here. So there's a high chances that we'll lose the mark. All right, so copy. I use computer, so easier to copy. Okay, so however, you all have to draw lah. Okay, no choice. I have to draw. Okay, so only need to draw this part lah. All right, so for this circuit, this is called the bridge rectifier. Okay, the bridge rectifier circuit. So diamond shape, okay, diode arrangement from left to right. Okay, this one also from left to right. Okay, from left to right. Okay, like that. Okay, next is we need to explain how the shape of the tracing output. So what does it mean by the shape of tracing output? Basically, you want us to explain why is it that it can turn into direct current. That means all the same shape, all the same direction. Okay. So first, we explain that. Okay, when alternating current is in positive half cycle. Okay, when alternating current is in positive half cycle, current flow from power source to, okay, from the power source here, it will pass through the diode K. From power source to diode K, resistor R, and then it will pass through the diode N. Okay, resistor R, diode M, and back to power source. Okay, like that. This is the first. After that, okay, when alternating current is in negative half cycle. Okay, current flow from power source to wait a minute. Uh, mm, okay. Current flow, when alternating current is in negative half cycle, current flow from power source uh to the wait, okay, pass through the L, okay, to diode L, resistor R, okay, after pass through the resistor, okay, it will pass through J, okay. Okay, diode J and back to power source, okay. Flow from power source to the L with resistor R, diode J and back. Okay, all right. Okay, direction of current through resistor R is in the same direction. Okay. Okay, direction of current through resistor R is in the same direction for both positive and negative mm, mm, the same direction for both positive and negative half cycle. Okay, positive and negative half cycle. Okay, so this explains why the screen of the cathode oscilloscope only show us all direct current, but it's supposed to be alternating current, but it shows that it is the cathode oscilloscope shows that it is um, direct current. Okay, and then the next part is how can be smoothing. Okay, how to smoothen. Okay, how to smoothen the non-smooth okay, the direct current, okay, it's not smooth. So how to smoothen it? We connect what? Connect capacitor. Okay, what is this? Capacitor. Okay, no. Capacitor. Okay, connect capacitor parallel to resistor R. Uh, just like that, enough. Because it only want you to uh, say state the method. Okay, state the method to smoothen the current. Okay, smoothen the current. So connect capacitor parallel. Sorry, not parallel. Parallel. Okay, parallel to resistor R. All right. Next. Okay, diagram 10.2 show a transistor circuit used to switch on a fire alarm. Okay, it says that, oh, this is BM. Okay, it says the alarm will sound when the potential difference across the 10 kilo ohm resistor is 4 volt. Calculate the potential difference across the thermistor. Okay, so you see here, this is very simple. Okay, it says the alarm will sound when the potential difference across the 10 kilo ohm resistor is 4 volt. So that means if here is 4 volt, then the transistor can turn on and the fire alarm can turn on. Okay, now, if this is 4 volt, then here will be how many volt? Very simple, right? Just 6. Here to here is 6 volt. So here is 4 volt. So 6 minus 4 is 2 lah. So here is also 2 volt. Here is only 2 volt, but okay, we need to show the calculation. So the potential difference across the meter, potential difference is 6 volt minus, okay, minus 4 volt. So you get 2 volt. Okay, 2 volt, the thermistor get 2 volt. Okay, second, resistance of the thermistor. Okay, what is the resistance of the thermistor? How much is the resistance? Okay, so if here is 2 volt, so that means here is 2 volt, here is 10 kilo ohm, so here how many kilo ohm? Okay, or how many volt lah? How many volt at the sorry, how much is the resistance of the thermistor? Okay. Okay, so this one is Okay, so we can write like this. So the potential difference across the thermistor, okay, so I put T lah, over the potential difference of the this is the potential difference at mm, the lower part. Okay, what do you call it? Oh, this one. Okay, this is base, this is emitter, so we say the potential difference between base emitter lah. Okay, so this potential difference between base emitter. Okay, so this ratio equals to the resistance of the thermistor over the resistance between the base emitter or resistance of the 10 kilo ohm resistor. Okay, so this is the one that we want to look for. Okay, so this one, the voltage is between base emitter is 4 volt. Okay, so this one, the resistance is how much? Wait, oh, sorry. Yeah, sorry. Must be sleepy already. Okay, must be sleepy already. Keep on making mistake. Okay, all right. So resistance of thermistor, this is what we are looking for. Okay, so this one is the potential difference at the thermistor. So it should be 2 volt lah. Okay, because the voltage between base emitter is 4. So this side is 2. Okay, here we already calculate, right? This one is 2. Okay, so resistance of the thermistor over this one is the resistance of this one lah. So it's 10 kilo ohm. Okay, so 10 kilo is 10,000 lah. Okay, so we calculate the resistance of the thermistor. So it should be 5,000. Okay, 5,000 ohm. All right. Next. All right. So let's look at this question. Okay, D. Table 10 show 4 transistor circuit W, X, Y, and Z used to switch on a 240 volt, 1000 watt spotlight. Okay. Study each characteristic in the transistor circuit and explain the suitability of each characteristic based on the following aspect. Okay, position of light dependent resistor, the use of resistor, the method of battery connection, and the use of relay switch. Okay, determine the transistor circuit that can switch on the spotlight in dim or night time. Okay, give reason for your choice. Okay, so you see in the question here already got say can switch on the spotlight in dim or night time. So don't, so that means in your explanation you cannot use back exactly the same why we do this so that light can automatically switch on in dim or night time. Okay, this kind of answer cannot. Okay, so Okay, so the first one, okay, position of light dependent resistor. Okay, this question we answer in table form lah. Okay, as usual, 10 mark question, table form. So these are the aspects or characteristic. Okay, this one is explanation. Okay, so the first aspect is the position of the LDR. So position of LDR, okay, this one is down here, this one up, this one down, this one also down. Okay, so which one is suitable, down or up? Okay, the answer is that the one at the bottom here is actually the better position. Why? Because this one, the transistor connect between the base and emitter. Okay, this is base, this is emitter. Okay, so the base okay, so yeah, okay, correct lah. Okay, LDR should connect between base and emitter. Okay, so how to write the answer? The question is position of light dependent resistor. So LDR LDR, okay, produce circuit. Okay, should be sorry, again, wrong sentence. Oh, okay. LDR should be connected across base and emitter terminal of transistor. Okay, and then explanation, be able to increase voltage across base and emitter. Okay, at 9. Okay, next. The uses of resistor R. Okay, this resistor R, do we need this resistor or not? Connect at the base. Okay, this one don't have, but these three have. So, do we need or not? Yes, we need them. We need this resistor. Okay, why is it that we need this resistor? Because you see, this is the base circuit right now. Okay, this is the base circuit. The current flow like this. Okay, the base circuit. Okay, the current of the base circuit. It looks like it flow like this. Wait, okay, flow like this. Okay, so if you do not have a resistor here, what happens is the current that pass through here, it will be very, very high. The current will be very, very high. Why? Because you see, if here no resistance, so that means basically the resistance here is near to zero. Okay, so it's very small. The resistance become very small over here. So I believe, if like this, then even with, sorry, one more time. Okay, we need this resistor here, okay, connect at the base, is because, yeah, like what I said just now, if we don't have this resistor, the resistance here will be extremely low. When the resistance is very low, then the current flow here, it will be very high, right or not? Okay, here current become very high. Okay, so when the current very high, it can cause the transistor to burn, okay, to get damaged. So that's why we need to connect a resistor here to limit the current that pass through the base, okay, or go into the base. Okay, a resistor should be connected to the base terminal. Okay, why? To limit current that flows into the uh, base terminal. Okay, next. Okay, the uses of the method of battery connection. Okay, the method of battery connection. So how is it that the batteries should be connected? So you see, actually you only have two choices. One is like this. This one positive, negative, positive, negative. This one positive, negative. Here. This one terbalik. This one negative, positive. Okay, so how the battery connection is supposed to be? So the correct one is this one, positive to the collector of the transistor, and then the negative is to the emitter. Okay, negative is to the emitter. So you can just look at this arrow, the arrow point downwards. So that means the current go from here, pass through, and then go down like this. Okay, so if the current pass through here, um, okay, follow the arrow of the transistor. So that means this side must be positive, this side must be negative. Then only the current can go from the top, go into the collector and then come out at the emitter. Okay, so mm, mm, method of battery connection. Okay, battery. Okay, should be connected where positive terminal to the collector, to the collector, and uh, Okay, our battery should be connected where positive terminal to the collector and negative terminal to the emitter. Okay, so why I want to connect like this? So that battery is forward bias. Okay, so that battery is forward bias to the transistor. Okay, next. Okay, next, the users of relay switch. Okay, so what is relay switch? This is the relay switch. This is a relay switch. So what is a relay switch? Okay, a relay switch is actually is an electromagnetic electromagnet, and the electromagnet, when got current pass through, the electromagnet will produce magnetic field, and then it can pull the switch, pull the switch and close the switch. So that means a relay switch is a switch where you can use it to turn on a circuit of higher voltage. Okay. So why like that? Because of safety reason. Okay, so that the electronics will not get damaged by the high voltage of the spotlight. Okay, the spotlight need high voltage, so connect to 240 volt. Okay, but the transistor is very small, so it cannot connect to voltage that are too high. If too high, then the transistor will be broken also. Okay. Okay, so that means we need the relay switch. Okay, relay switch should be present. Okay, relay switch should be present. Can be used to switch on a high voltage circuit with small voltage circuit. Okay. Okay, another reason why is it that you need to use relay switch is because you see the spotlight actually need 240 volt. Okay, the spotlight need 240 volt, but the transistor is actually is a very small electronic component. So it definitely cannot handle 240 volt. So the transistor only can be used for low voltage electronics like that. Okay, low voltage the tools. Okay. So you cannot connect the high voltage to the transistor circuit. So that's why you need a relay switch. The relay switch is like the middleman, like that, the person at the center. So you turn on the transistor, and then the transistor will turn on the relay switch. So the relay switch will turn on the circuit for the spotlight. Okay, like that. And it's also more safe. That means the switch that you press is the switch for low voltage, the 6 volt only. You don't need to press a switch that is 240 volt. Okay, even if got anything happen, the 6 volt is not going to kill you. Okay, But if anything happen, the 240 volt is dangerous. Okay. Okay, so determine that so okay, we discussed all of them already. So we choose lah. So the most suitable one is this one lah, circuit W. Circuit W is the most suitable. So you say W is most suitable, and then you copy back lah. Because okay, blah 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 blah. This one aspect, then you copy back, put inside here, like that. Complete. Okay, finish. Okay, so okay, so this is the section B from the paper 2 of the Kelantan trial paper. Okay, Kelantan trial paper. Wait,